Then you can use this component form to find the magnitude of this vector. So the length of this vector v, by the distance formula, you know this is equal to the square root of a minus 0 square plus b minus 0 square, right? Because this point is the origin. It has the 0, 0 as the coordinates. So you have the square root of a square plus b square as the magnitude of this vector, which is in this component form. Now let's look at the page 611. We have the problem 20. So we need to find the magnitude and the direction angle of this vector. So page 611, problem 20. Our vector is -1 and the root of 3. So the two components, the first component is the -1 and the second component is root of 3. Now let's first find the magnitude, right? So the magnitude of v is equal to the square root of a square plus b square, and this is equal to 1 square plus square of root of 3, and this is equal to 1 plus 3, so that is equal to 2. So now we can get sine theta. Theta is the direction angle of this vector. So sine theta is equal to b over the magnitude of this vector. So this is equal to the root of 3 over 2. And for this type of problem, we need to draw this vector in the rectangular plane to help us to determine the position of the direction angle. So -1 here and root of 3 here. So it's like this. Okay. So this is the direction angle. So now, if you use the arc sine root of 3 over 2, then you know this guy is equal to pi over 3, right? Or say the 60 degrees. But this theta is in the quadrant 2, so actually theta as the obtuse solution to this equation should be equal to 180 degrees minus this 60 degrees. So that should be equal to 120 degrees. If you do not draw this vector in this rectangular plane, then you have no idea which angle you should use as the solution to this equation. Okay, so draw this vector in this rectangular plane tells you the position of this angle, and you know this angle is obtuse angle, then you can find the solution, this obtuse solution. Any question? Now let's see how we add two vectors in the component forms. So we talk about vector sum, scalar product, and dot product. This is the new thing in component form. And let's first draw the two vectors in the rectangular plane. And this is my vector A. And it has the A1, B1 as the coordinates of the terminal point. So now to add the vector A and vector B, I need to place vector B so that the initial point of this vector B coincides with the terminal point of this vector A. So right now, let me draw another vector B. Let me use the red. So this is the vector B. And for the vector B, okay, right now, vector A in the component form is like this, and the vector B in the component form is like this. So that means if I draw the two attitudes from these 2 points to the x-axis, then this guy is the A2, right? This is just the length of the horizontal component of this vector B. And this guy is A1. Now let's draw the two parallels, okay, two horizontal lines through the initial point and the terminal point of this vector B. Then this is the B1. And this is the B2. Okay. So now you can get the coordinates of this terminal point. So the x coordinate, that should be the A1 plus A2. And the y coordinate is equal to B1 plus B2. Okay.